All right, welcome back to the Air Transportation Seminar, and we're looking at research design, research methodologies. And so, where we left off, we kind of just did an introduction, and now that we're in week 2, what I'd like to do is start getting your brains to think in a certain way and start coming up with some creative ideas for your research topic. But before we can do that, what I really have to do is kind of outline a couple options with respect to the type of research you can do, just so that you can start thinking ahead in terms of your topic. And we will go over these different types of studies again in a little bit more detail in one of the other lectures down the line. But really what we're trying to do here in terms of why I'm talking about this is to help you come up with some ideas defining what your overall topic will be, what the purpose of that topic will be, and then defining what we would call operational definitions as well as the variables, defining the variables of the study, basically what it is you're trying to measure. And so I just wanted to get a little bit ahead of the game in terms of the different types of studies here. And we've got really two main branches of research studies that you can do, and then you can combine them as well. And really what we're going to focus on are the quantitative and qualitative studies, but I wanted you to be aware that there is a combined version where you could do a combination thereof of the two types of studies in any type of research. So let's start off with quantitative studies. And really what we're looking at is intervention, associational, or descriptive quantitative studies. We'll start off with descriptive right here on the right-hand side. Descriptive is basically a survey type where you get basic data information with a given amount of time, with a certain amount of time. So your cross-sectional or longitudinal design, your cross-sectional design would be basically the moment that you collect the data and just look at it from that snapshot of time. Whereas your longitudinal design will be over time. You'll be collecting data over, let's say, a year or 2 years, so on and so forth. So let me see if I can come up with an example of a descriptive survey quantitative design. So you're trying to get some actual numbers. So in terms of a quantitative design, you've always got to look at quantitative as value-based, numbers associated with the research. And so descriptive would be along the lines of looking at performance, let's say, of, let's say you want to look at a team's performance over a year, right? How much they are performing in terms of the case studies that they have, how many case studies they're closing or cases that they're closing in a company. So for example, we'll take Boeing, and you've got a maintenance department in Boeing, and there's different groups of that maintenance department. The maintenance department's pretty large, right? If you think of a large company like Boeing, and they can be in all different states, and you want to see how effective these the maintenance guys are doing with respect to certain types of cases at the different states. And so what you'll do is you'll collect the data associated with each team and quantify their performance based off the number of cases left open versus the number of cases closed. And you can see in a cross-sectional design, if you're looking at a snapshot in time, how well did they do in 2019, for example. You could compare and contrast through a descriptive quantitative statistical analysis how well each group is doing over a set period of time. Longitudinal would be looking at how they perform year by year by year. That will give you an idea of how things are going, right? As a manager, that's important in terms of purpose of that design to see what is going on with respect to the company in terms of performance. And then you might ask yourself, okay, if I'm seeing that, let's say my Seattle maintenance crew versus my Texas maintenance crew are doing way better with the same types of cases. They're closing 100% of their cases within a month, whereas Texas is closing them only 50% each month, and they're struggling. You might want to look at to why they're doing that, and that might be associational. And the next study would be an associational design. So that's a good leadway as to this different type of quantitative study. An associational design would be either correlational or causal comparative. You may have heard the term correlation before, and we know the term correlation doesn't mean causation, but it might give you some ideas as to what might be causing the reasons for it. And that's why we have this exploratory design and predictive design. You could design the research to be able to predict how well a group will do based off some correlations. Now, again, remember that correlation doesn't mean causation, but it might give you an idea as to if there's a strong correlation, maybe it might be a reason why. Again, being aware of the fact that it might not be the cause for it, but if you do that study and find that it could be predictive of results, you might want to use it, right? So an example would be you wanted to find, now that you know that the Seattle group is doing really well with, let's say closing cases that are associated with wing repair, whereas the Texas maintenance group is struggling about 50%, and they're the same size team. Now, I might want to do either an exploratory or predictive design and look at the correlation. Well, if I see that if they're the same size team, but the experience level at the Seattle-based, the variable of experience in the Seattle-based company has on average 5 years more experience at any given time, the group has an average 5 years greater experience with repairs in the wing compared to the Texas design. Well, that's kind of clear that by correlation, we can predict that the greater the experience level with a particular problem, the faster or more effective the performance will be with that closure of that case study. And so as a manager, what I would do is use that data to assign or move around or hire people with the right amount of experience for certain problem cases. For example, in Texas, if I were going to hire new people or move them around or get requests from other branches for mechanics to move from one place to another, I would want to look at which ones have higher experience in wing design repair and place them in Texas, or approve them to move to Texas if that's something they want. So that really gives managers and supervisors a chance to explain what they need given their situation based off a quantitative study. A causal comparative is a better associational design. It's more robust to see what the effect is or what the cause is, effect or cause, in more detail. It's stronger than a correlation. You're not looking at correlation. You're actually looking at what the effect is of a particular variable on another variable. You could use it similar to the example I had in terms of experience. What's the effect of experience on closure rate of a particular case study, and look at it from a causal comparative design. These are all designs, and so how you design it will determine what your outcome will be. They're both associational in that sense, my examples that I gave you, and that's really kind of hopefully giving you a trigger as to the difference between a descriptive versus an associational design study. Then you can have an intervention design, which is really experimental. You can have a weak, quasi, or true. I'm not too worried about the different types of experimental. This is a little bit more detailed, but I just wanted to give you an idea. So an experimental design would be being able to do it in a lab, for example, or really be able to compare the effect of intervention compared to not having intervention. So the example I could give is medicine. Medicinal studies are experimental by nature because what they do is they give a group of people an X version of a drug, and then they don't give another group. So they have a base group and then an experimental group. And so by doing that, they can see if there's a true effect of that drug on, let's say, a disease, and that will give you a true design or an experimental design where you're finding out really what's happening between two groups with an intervention involved, where you're intervening, where you're adding or giving them a specific thing that you're looking at in terms of its effectiveness. So let's look at it in terms of aviation. You might want to see what is the effect of automation versus steam gauges, right? And so you want to see one group and trying to really of pilots and trying to really make that group equivalent. So all commercial pilots with the same amount of hours, same ratings, same sort of experience versus another group, same commercial group as well, but two different sets of people. And you want to give one group, automation and one group steam gauges. And you're trying to see the difference between the group in terms of performance, let's say, of a cross-country instrument flight with an approach. And then finding a way to measure performance. You can see what the intervention is of automation with respect to those two groups. That's just an example that I'm giving with respect to quantitative studies. So you can see you can have different types of quantitative studies. These are the type of studies I would like us to use for this class, just because they're a little easier to perform in terms of the time frame that we have, but also they are a little bit more robust in terms of being able to determine effectiveness or differences or trying to measure something quantitatively. You can have qualitative studies, and qualitative studies is really associated with descriptive studies. So trying to see if there's any, you can look at grounded theory based off a theory and then kind of describing and growing that theory based off at looking at different groups of people or a certain person and kind of interviewing them and seeing if there's any phenomena that occurs with respect to the type of flying they do, for example. Ethnographic, you're looking at case studies. That's kind of what a lot of aviation research has been in the past, is mostly ethnographic case study based and just coming up with reasons why certain things happened based off a case study. So qualitative is really just more descriptive in the sense of explaining it in terms of words, trying to see if there's any phenomena or logical comprehension based off case studies, based off interviews, based off just really examining and observing. There's no real comparative in terms of values or numbers or statistics associated as clearly as there are with quantitative studies. So you could have a quantitative study versus a qualitative study. And so maybe you've probably done mostly qualitative studies based off case studies in other classes. So like in safety, you might have done a case study looking at a crash or multiple types of crashes and coming up with a logical reason as to why those crashes occur, and then you come up with a result saying that, because of X, Y, Z, these crashes occur. And so that's purely a qualitative study. You can see where that can be a combined quantitative and qualitative. In that example that I just gave, you could have a qualitative case study example where you're looking at case studies, a group of case studies, and kind of trying to come up with a pattern, and then looking at it from a descriptive point of view, looking at the values of the number of crashes and trying to come up with either a descriptive or correlational quantitative study or quantitative result. So that's combined quantitative versus qualitative studies. All right, so those are the types of studies, and we'll go into a little bit more detail, and I'll give some more examples and a couple classes down the line. I think it's week 5 or so after we do some literature review. Because once you start doing some literature reviews, you'll be coming across these types of studies that the literature will say that they did, the previous studies. And now at least giving you a brief introduction to it will give you an idea of kind of what they probably did and how they approached that research and what the results really mean. And so you'll be able to at least get a grounding as to what's going on with respect to the study that you research. And then once we do some more, we can really examine those literature reviews and see, how they came up with looking at it from a quantitative study or not. All right. So, what are the stages in research? So, what are the steps really, let's say, where you're at right now? You've got to first select a research problem. So, how do I want to select a research problem? And that's where we're at right now. We're kind of just brainstorming, kind of thinking about all the different experiences we've had in different aviation courses. And you want to identify the research problem. What is a problem you want to solve? It has to have a good research study has to have some sort of implication to the body of research that you're doing, or has to have an implication to the industry that you're trying to apply it to. So you want to specify the issue that you want to study. So for example, you want to say, okay, I want to look at the effectiveness of aviation maintenance teams in a company based on experience. And so that's specifying the issue that you want to study, and you always want to provide a justification or rationale for studying it. So what do I mean by that? What's the purpose, right? What is the implication? Well, back to that example, the implication is that, hey, if I find out that that there is a correlation, for example, of closure rates of open cases of maintenance with respect to a specific type of experience based off the mechanic group that you've got, well, then I want to really establish teams that will be getting those sort of cases in that way, or make sure that the cases go to those specific teams that have that experience or knowledge base, rather than just randomly selecting whichever is convenient based off, let's say, maybe in the past that company was doing it based off location, ease of bringing that maintenance requirement to Texas because it's closer to Texas. Location was the variable that they're using. But if you look at it from a grand scheme of things, you might say, well, once I look at this data, I find out that, well, yes, it might cost a little bit more to get that equipment to Seattle, but they will definitely close it within a month, whereas Texas will spend 2 to 3 months, and that will end up costing a little bit more in terms of time and opportunity cost. So that's the rationale for studying it, right? And then you want to suggest the importance or significance of the study. I just did that in terms of, it's going to save money basically at the end of the day, because if we choose it correctly or make it more efficient, we're going to be, closing maintenance records faster, being more efficient, moving along with the projects that we need to. So research problems emerge from various needs. So some of these questions are associated with education, just because I'm in it. So you want to, let's say, improve classroom participation. So I want to see, how can I do that as an educator? How can I improve student participation? Well, I might want to look at ways or methods that are out there and seeing how effective it might be, and seeing if there are any implications to that. So they are usually broad in scope, and that's what we're doing. We're at the broad in scope stage. We're really in just stage 1, and that's this week's class. Week 2 is really stage 1, selecting a research problem, and that's your assignment for the week. So you want to, kind of be broad, in terms of defining what you're studying or going to try and study. So for example, here I've got, what is the effect of an integrated science curriculum? So the words integrated science curriculum is kind of a new thing that we're exploring on students' attitudes towards science. So we want to see if we can increase participation by looking at attitudes, with respect to science, if I use this new thing called an integrated science curriculum, right? So you want to be broad. So let's say the next hottest thing in pilot studies is the use of an Apple Watch for, let's say, notifications of traffic, right? It doesn't matter if you have an iPad or whatever. You're just saying like a wearable device is going to give you better knowledge of where things are, whether it's an Apple Watch or back in the day, a few years ago, Google Glass started coming up with that. Maybe wearing a Google Glass will make you better with augmented reality as to where traffic is. So an example for that, I'm just, spitballing here, is what is the effect of augmented reality on pilots' traffic awareness, right? And we could actually measure that, right? So the measurement would be to see how well they pick out traffic compared to other means of doing that. And so the next step would be to also define the purpose, right? Remember, selecting a research problem is specifying the issue. So the issue would be, in the example I just gave, is looking at traffic avoidance or traffic awareness. What's the rationale? Well, because we want to just see, or justification, we want to see if this new tool will be good for pilots to use. And what's the importance or significance of the study? Well, the significance, just by thinking about it, the last few weeks we've had some mid-air collisions traffic-wise. So the significance is we're trying to find means or methods to reduce traffic collision, right? Air traffic collisions, mid-air collisions, excuse me. So the purpose of this study, if we look at it from this research purpose statement, the purpose of the study is to determine the effect of an integrated science curriculum has on students' attitudes towards science. So it's basically a reciprocal of what the question is. You're trying to find the purpose. So if my question was, what is the effect of augmented reality systems on pilots' ability to avoid mid-air collisions, the purpose of the study is to determine the effect of augmented reality devices on pilots' effectiveness or pilots' ability to avoid mid-air collisions, right? So that's your first step. And what I want you to do for this week, and you'll see it later in the document, is that I want you to come up with at least 3 research topics, problems overall, and I want you to specify the issue, provide the justification, and suggest an importance or significance to the study. And so while this bullet does not have the significance aspect of it, I would add another sentence or another paragraph kind of defining the significance. It should be a couple sentences at least. So the significance is recently there's been an increase in mid-air collisions in Alaska, and the goal is to mitigate these risks, and we're trying to find different methods that are effective and usable for pilots to utilize in the cockpit to avoid mid-air collisions. So you can see that this is kind of hopefully getting interesting in the sense that you really want to utilize, quantify how good something is. And it can go either way, in some ways. In most of the time, you want to see if something's going to be effective. But sometimes you also want to explore if something's actually being a detriment. And so, if we look at some of the tools that are out there, maybe you might find, well, this tool is really not helping pilots. So, there's a number of FAA tools out there, and you might say, well, this document or this tool is not really being effective. So you actually might want to investigate whether it's a detriment or actually a help to pilots. And then your study will be used or could be used to make decisions as to whether to use a specific tool or not use a tool, given the significance or the rationale. So then once you've got a few problems, the next step is to review the literature. And really, let me clarify that in some cases, some people would say you want to review literature first before you select a research problem. Well, that depends, right? So if you already are involved in an industry and you're kind of aware already of some of the problems, you could come up with research problem first, then reviewing the literature. But if you're not really sure what's going on, you really want to review some basic literature. So you could start off with basic literature, or Google or the news, or talking to experts and asking them what their concerns are in aviation, and then see if there's any research done accordingly to that topic. So it just depends on how you want to approach the exercise. Some people will review literature first or get an idea of what some problems are out there, then define the research problem or topic that you're looking at. Or they can define an overall broad topic, like, for example, drones. Just thinking, okay, drones. Drones is a hot topic in aviation. Let me see what research is out there, kind of see what topics have been looked at, and then come up with your own research problem and then review the literature again specifically to that research problem that you came up with. So once you've stated and have a good idea of what the overall topic is, what you want to do is what's called a lit review or literature review. So you want to locate the appropriate sources, select those resources pertinent to your problem, and it doesn't have to be specifically to that topic. So if I'm looking at augmented reality and pilots' ability to mitigate mid-air collisions, I might look at augmented reality on engineers being able to use it for hazard analysis, for example. Like, let's say there's a research paper that's already out there on augmented reality in different industries. As long as it's linkable, where it makes sense that, hey, yeah, let me see if that research topic and the research results from that topic produced positive results and could be replicated in an aviation sense, then yes, you want to select that resource because it's pertinent to your problem. Then you want to summarize the results in an organized and coherent manner. So you're basically trying to see what's out there, what has been done. Is there something that you want to replicate and maybe edit slightly, or just replicate completely and see if it's truly able to be valid? Because you want to make sure, just because one person did it and said, yep, these are the results, it doesn't mean that it's always going to be the case. And sometimes you might want to utilize that research to say, I'm going to replicate that or try and duplicate it and see if I get the same results. And if you get the same results, then you're solidifying those implications from that previous literature. So we'll go into literature review in a little bit more detail on how to do those. Then you want to design the research. So like I said, you want to define the design and methodology, right? Is it quantitative that you're going to do? Is it qualitative? So back to my example, just briefly. So if I'm looking at augmented reality and pilots' ability to avoid mid-air collisions, I would want to do it quantitatively. So I would like to give some scenarios, maybe a simulation, kind of put a student in a simulator somehow if I could, or multiple students, and see how well they are able to pick out traffic. There's different ways, either a simulator or real life, actually, if you had the funding for it, and see if they're able to pick out traffic with the augmented reality versus another tool versus no tools, right? And so that would be quantitative. Then I can see and base that quantitative analysis on time. How quickly will they be able to point out that traffic, right, in a given condition? So that would be an example of quantitative. Qualitative would be maybe interviewing 100 pilots and seeing what they feel or think will be the effectiveness of that augmented reality device. And from that, you can see if there's a phenomena associated with that technology with respect to pilots. And that would be descriptive as well as qualitative in that sense. Descriptive in the sense of not quantitative descriptive, where you're looking at results on based off numbers or charts or things like that, but descriptive in terms of words, looking at what they're really saying and coming up with an overall logical idea that they're all saying, right? So that's qualitative. So it just depends on what emerges during that investigation. So that's designing the research. Then you'll collect the data. So dependent on what type of research you're doing, you'll collect the data, whether it's from participants, whether it's from ex post facto, meaning past data results from other places, or comparing data from different sets. Then you'll want to look at your instrument, your methodology, and then actually gathering. So once you identify and select the participants, that's sampling, then you'll choose what the instrument will be used to measure it, and then the procedures, that's your methodology of collecting the data, and then collecting that data from the participants is the actual data collection process. Then we'll do some basic stats. I'll show you some of the statistics that we can use in this class. That's straightforward, but should be fun. Hopefully we could do some basic average differences. Those are called t-tests. You can do ANOVA, analysis of variance with various variables. Then you want to look at regression analysis. You could do a basic regression analysis in this class. I think that's suitable. So it just depends on what your data and what your design is really going to involve. So this is hopefully giving you an idea of the overarching plan that you'll be doing. You'll be coming up right now. This week is selecting the research problem. Next week we'll be reviewing the literature. And then the following weeks after that, I'll be helping you designing that research plan to design the data and analyzing the data. Then interpreting the findings and conclusions really plays a role on how you defined your hypotheses, and then what are the plausible explanations for your results, and what does that really imply with respect to your industry that you're applying that study to, right? Is it going to really help with respect to your industry? Is it going to do anything that's going to actually make it better, right? So back to my example, is that augmented reality device really going to help, and should we really try and push for that to happen? It's kind of like that ADS-B thing. I know there was some research done with that previously, and then there's research done with TISB and weather in the cockpit, and they're looking at its effectiveness and how to implement it in the general aviation sense, and how they're going to see how effective it really is in terms of different problems there, right? All right, so some of the questions you wanted to ask yourself before you begin defining your research problem, right? Your practical questions. How practical is it that you're doing? You don't want to just study something that's not really going to produce anything that's of value, right? So you want to really see what brings value to it. And I'll give you some examples at the end of this class here. Then you want to define the constructs and operational definitions. So constructs are abstractions that cannot be observed directly. So intelligence, creativity, anxiety, motivation, and self-concept. Those are all constructs that typically happen in the mind, right? And sometimes you want to use a construct to see what it does to performance, for example, or something along those lines. And so that's why you want to be able to use operational definitions, because someone's definition of, for example, creativity is going to be different than your definition of creativity. And so you want to be really clear how you're going to measure creativity in your research study, so that if someone wanted to replicate your research and see if you were correct, or your study was producing results that are generalizable to a bigger population or sample size, you want to be able to be on the same apples to apples versus apples to oranges, if that makes any sense. You want to have the same measurement level for a given construct. So when would we use construct in terms of aviation? Let me give you an example. Motivation, right? So I'm a flight instructor, and I might want to see what is the effect of the levels of motivation from the flight instructor, right? The flight instructor's motivation being brought into a class or to a flight on pilot's performance, right? So you might want to investigate, and see what motivation, or self-esteem or self-concept is with respect to performance of the student. I could even make that a little bit more complex. What is the effect of CFI motivation for a given flight with respect to the student pilot's self-concept, how they perceive themselves as a pilot, their self-efficacy is another word that we use here. How good do they think they are going into that classroom? If they have low self-efficacy or self-concept, but the CFI has high motivation, how effective will that motivation be to overcome that self-efficacy, right? And so that tool might help CFIs understand the relationship of their motivation level with self-concept, and whether they can alter their motivation levels or be aware of their motivation levels if it's effective to a low self-concept or low self-efficacy student, right? Being aware that there is a correlation or strong correlation between the two. That would be an example of utilizing two constructs to measure something in research. So an operational definition defines a construct or defines any variable in your study, whatever it may be, so that a research can perform and measure the construct. So I gave you an example with respect to intelligence. For this study, intelligence is defined as student scores on the Wechsler Intelligence Scale for children. So back to my CFI motivation example. Motivation in this study would be defined as the score on the flight instructor motivational scale by the FAA, for example. There isn't one. I'm just saying that, let's say there was one that was created, valid, and reliable, able to produce the same numbers and results for a given flight instructor's motivation. You could use that to define how you're going to measure motivation, right? There's different ways to measure different things. You've probably taken a million different IQ tests online. So just to say, I'm going to use, how does IQ affect happiness, right? For example, if that was a research study that you were doing, Well, you've got to use the same IQ test for everyone. You can't just use 50 different IQ tests and then try and see if there's a correlation to their happiness. And again, how do you measure happiness? There's got to be one scale or measurement tool that you're going to use to be able to compare apples to apples. The same IQ test to the same happiness score should be able to give you an idea of that correlation. So operational definition ensures that everyone clearly understands the meaning of the construct within a given research setting. And so then your variables, you typically, for the group, for this class, we're going to use two variables, an x and y, basically the effect of one thing on another. And so examples of variables would be height, math test scores, IQ, a construct could be one, gender, annual income. Those are all variables that you want to see how does it have an effect on another variable. And so in the context of a research study, in terms of what you're doing, you're investigating the relationship between variables, different variables. So you might want to look at what's the difference between instructional method in this case. So if I was a CFI, what is the instructional method and the relationship with so that's one, the overall variable will be method of instruction, and then I want to compare that to performance on an exam, right? So that would be another variable that I can measure as a graph, if you want to think about it that way. What you're really doing is trying to design a graph, an X and Y graph. If I can draw on this real quick. If I were to draw, really what you're trying to come up with is two variables that you're trying to measure, right? And that's really what we're doing, is saying if y is going to be your grade on the exam and x is going to be the, different types of instruction, I'm just going to call it INS, instruction. And let's say this is lecture, this is self-paced, and this is cooperative learning, these three lines here. And you see that these are the scores, right? Clearly you can see this is a very basic example. If I were to measure the differences between these and do a statistical analysis, just by looking at it in terms of this example, we can see that lecture-based does the better job for grade performance with respect to that. And so you're trying to just measure variables. You're going to see what variable affects the other variable, and you're trying to find an independent versus dependent. We'll talk about dependent and independent variables in another class. But what's the effect of x on y, basically, if I look at it from this point of view? And that's what you're trying to come up with today's or this week's topic or this week's assignment, is trying to think of your research problem topic as to what is the x and what's the y and how are they going to potentially react with each other. But just in an overall point of view, what are the two topics that you're going to, or two variables that you're going to look at in an overall topic, right? What their effects are on each other. So let's look at a few examples that I've come up with just for you to think about. What is the effect of pilot attention? And so just from my discussion, I've got to define that construct of attention and say, okay, what does attention mean? That'll be my operational definition. And how am I going to measure it? And then on performance in an instrument approach, right? So an instrument approach, we can define the instrument approach as, let's say we take them all and do a VOR approach at some airport, the same airport, right? VOR X, same airport. Performance can be some sort of scale measurement score on, there's a couple things out there now. If you guys have never seen something called Cloud Ahoy, they have actually some tools to measure performance. They give scores based off how good you are on your altitudes, how well you perform or shoot the approach in terms of being on the correct navigational line, altitudes, as well as your lateral and vertical performance with respect to that. And that can give you a score out of 100. So you could use that. And then attention, what is the effect of attention? Well, it depends on how I'm going to define attention, and that could be, let's say, again, this is probably not correct in terms of this, but just to give you an example, their heart rate level. The higher the heart rate, the closer you are to a base heart rate of what would be defined as attention, or normal attention, high attention, and then low attention. You could look at it that way. Maybe you might want to look at just the there was a study I was involved with looking at pilot, what was the word we used? Pilot, I can't think of it off the top of my head right now, but pilot, it was attention, but what we used was a heart rate monitor as well as sweat monitor. Actually, we put that around on their fingers, just like a perspiration monitor to see, we associated that with attention and actually came up with a score for attention on a scale that was valid, reliable, and acceptable in research. And that was able to help us with respect to comparing that to other students or other pilots and then their performance given on a scale. So that was just to give you an example there to think about. So if I were to, how do I turn this off here? 1 second. Take off the drawing. There you go. What are the constructs, right? So the constructs are attention and performance, right? What are the operational definitions? Attention is an aggregate score, meaning a combinational score on perspiration device. There's a device we can measure the perspiration level and heart rate, right? And a heart rate monitor. You could say that performance is based on a scale scored on the app CloudAhoy that measures GPS position on a compared to official instrument approach, right? So you can actually utilize that to measure the pilot's GPS position and compare to what the GPS position should be on that official instrument approach, and then score it accordingly. So if you use the same one over and over again, you'd be able to actually score everyone's instrument approach equivalently. What are the variables being measured? The variables is pilot attention versus pilot performance. So again, if I were to draw that out in terms of X and Y, what would I put on the X value? So I want you to think about that for a second while I set it up. And what would I put on the Y value? Well, makes sense, right? That I want to see what is the effect of pilot attention on pilot performance. And typically, if you say it that way, the performance would be on the Y, what's your acting on, and of is the attention level. So if we look at it, it looks like that. There's a level of attention here. This score of attention will give you the greatest performance. Then we've got ourselves a if that happens every single time, and that's the average, let's say, scatter plot that we do here between multiple students or pilots, and we find that this is the data result that we get, we can see that that's really what we're looking at. What's the attention with respect to performance? And we'll do more of these. I kind of enjoy them. They're kind of cool to think through and think about in terms of research. What could be the purpose, reason for the study to be conducted? In other words, its implications, right? And so what what are the purpose is to see really the purpose is to investigate the effect of attention on performance in flight, right? In flight. And what's the implication? If there was a way to continually measure attention in the cockpit, we can alert pilots if they are drifting as it will potentially affect performance if this study, if my hypotheses are proven in this study or not proven. You really shouldn't say the word proven, but is measured in this study or demonstrated in this study, right? So the purpose is to investigate the effect of attention on performance in flight. What's the implication, right? So the implication is if we find that attention plays a strong role in terms of performance or has a very high correlation to performance, we can say that, if there's means, we want to find ways to continually monitor attention in the cockpit. And if attention drops below a level that's unacceptable with respect to performance, then we'd have an alert system to let the pilots know in the cockpit that that's occurring, to bring back their attention levels with respect to their task. That way they can perform the task appropriately. So that's just an example. I've got a couple here. How effective is an angle of attack indicator in terms of pilot performance and a stall recovery? I'd like you to think about the constructs, give the operational definitions, and what are the variables being measured, and then a purpose, reason for the study. And then what is the effective convenience of recycling opportunities at airports on user use? Again, I'd like you to come up with all these items here. And then what is the effect of new software, whether from the FAA, on pilot decision making on cross-country flights? These will be your assignments, as well as your own 3 topics that you're going to come up with for this week. Okay, and so midweek I'm going to touch base and have go over these 3 examples. So these will be due for midweek. I'll post it on Blackboard. And then I'd like you to think about the variables that you can think of here. This is just to help you out. Drones, these are different overall topics or variables that you can use for an overall topic. So hopefully engaging your mind into thinking a certain way. Drones, airport security, passenger decision on airlines, depending on what the airline does. You can look at baggage costs. You can look at policies. You can see what the effect of policies on passenger decision or their willingness to fly with an airline based off their policies or definitions. Pilot performance, fatigue, training type, so whether they're 141 versus 61 is a good one. Training history, so where they trained maybe, what type of training they did, not just part 141 versus 61, but what type of training they did. That can also work for maintenance. Pilot experience, again, kind of relating it to, did they do gliders? What sort of ratings did they have? How does that affect their performance on, an emergency procedure, for example? The best example would be the Hudson River, right? So that pilot experience really played a role in effectively landing that airplane safely. Off-airport safety, that's kind of Alaska flying. That's an overall topic that could be of very good benefit here if you can come up with some good ideas. Weather, risk analysis, automation, so autopilot systems, how can that play a role? And then looking at it with maybe automation in Alaska flying. I don't know. I'm just coming up with some ideas. Airline management decisions, passenger preferences, I kind of mentioned that. Simulator use and performance on a student, let's say, if they use X amount of hours on simulator use, what's their performance in instrument approaches or, their ability to get a license, their skill set to get a license in terms of time. Profile correlations are always very interesting. How can you create a profile, measure a profile to correlate it to performance as well? Air Force was very big into that recently, trying to collect profile data and seeing whether they'd fit well in a specific aircraft type, what their aircraft that they're going to be flying, whether they'll perform well or not based off a profile. So creating a profile tool would be an interesting research study as well. So that's for week 2, guys. Hopefully that was helpful. Hopefully that gave you some ideas. I'm going to post this on Blackboard, and hopefully if you have any questions, let me know.